This only works if there are no other restrictions. So we know that this has to be with replacement. And when I mean no other restrictions, I'm saying like literally I can have any digits I want to use. So if I look about my positions again, 6-digit pin. So I've got these 6 spaces here. And similarly, I don't even have to do that anymore. I actually know it's just going to be 10 to the power, how many positions I have. It's just 10 to the power 6, right, for that first one. So let's put that over there, 10 to the power 6. What if I can't have repetition of digits then? What's going to happen? Yeah.
Okay. Times by the original number.
So,
you have the original number times by like 1 times by 1 less.
oh, okay. So what do I put in the first space? How many choices do I have for the first one? 10. Because I still have 0 to 9, but then what? 9. And you can see how it decreases by each time. Because once you use one of those digits, I can't use it again. It's kind of like those cards, right? I've just kind of taken that card out. I can't use it again, right? And multiply these all together, and that is the number of 6-digit pins that you can create without repetition, right? How many is that, out of curiosity?
15120.
15120. Quite a lot. 151,200. Even though we can't repeat them. What about if they have to end in an odd number? Now, when I'm looking at these different parts, okay, these are all kind of separate situations. So I'm not like stacking them on, right? These are all separate cases. So the only requirement is that it ends in an odd digit, right? So how many choices do I have for the first one? 10. It actually doesn't matter, right? The only restriction is the ending thing. So I can don't have to worry about it until I get to the end. But then how are we going to have here? So let's double check. 1, 3, 5, 7, 9. These are my odd numbers, right? So I have 5 choices there. Yeah, exactly right. And I multiply them all together. And that would just be 10 to the power 5 times 5. Yeah. And I can evaluate that too. Can you do that for me? 500. 500,000. Cool. Can we work this one out now? D, only odd. 5 to the power, yeah. And actually, this you can almost think about. You could draw it out, and there's nothing wrong with drawing it out. Right? That's 5, 5, 5, 5, 5, because that's all the odd ones. Okay? And I can multiply them all together. But what you notice is this is just 5 to the power 6, which is actually this situation here, right? Because for each of them, it doesn't matter. There's no restrictions with the repetitions, right? I have 5 odd digits I can choose from, and there's 6 kind of slots that I can put them in, right? Okay, so 5 to the power 6. Which one, sorry? D? B. Yeah, go explain.
Start off with 10 options, right? But then you lose one, so it's 10 times 9. And then you lose another one.
So can you simply calculate for 10 exclamation mark?
Okay. Now I will talk about the exclamation mark, right? But before we get onto that, let's just draw it out for now and use that. Is that okay? Can we do that? Is that all right? I don't want to spoil anything too much. All right. Do you want to try another one for me? I think with the restrictions things, we kind of have to be careful, right? Because sometimes there are implied restrictions. And this one, I haven't really mentioned it explicitly. But how many people in a swimming race? Is it 8, by the way, in a swimming race? 10. Okay. Well, this one we've got 8. Maybe they couldn't find enough people. So how many possible kind of finishes can we have? And I haven't said anything about the restrictions, but hopefully you've got an idea of when you draw out these positions, because you've got 8 there, how many possible ones do we have for the first one? There's 8 people in total, so there's 8. But like you guys are kind of saying, it's not possible for, if someone finishes, whoop, I've won, oh, I'm going to go back over the line, and then I'm going to come back second again, right? So I have one less option here now. I only have 7. And then 6, 5, 4, 3, 2, 1. When you multiply them all together, can you calculate it and tell me what you get?
I now remember, it's called factorial.
Calculate it. We are going to be looking at that, but calculate it for now. What do you get?
It's 8 factorial equals 40,000.
40,300. Okay. Now,
And 20.
on 20. Okay, cool. Now B.
What do you mean by that question?
What if I'm only interested in how many different ways people can finish first, second, and third? How does that change the question? I can't quite read that. There's only 3 slots. Yeah, right. So, if I'm only interested in how many ways we can finish first, second, and third, there's now only 3 slots. But still, I have the same number of choices, right? I still have 8 choices. And then, same rules apply. Once I finish the race, I can't go back into it. So there's 1 less, and I multiply them all together. Okay? So what's that? 56 times 6, 300, 336? Yeah, easy. So far less because we have we have much less kind of spaces or positions now, right? Let's look at one more example, and then let you try the exercise yourselves. How many are possible? We're drawing lottery. We're drawing lottery numbers out, and you know people love buying lottery tickets because they think they've got a big chance here. But how many are we drawing? We're going to draw out 6. If I'm drawing out 6, again, I know that's my positions. How many do I have for each choice? 45. And I don't know if you've watched Lotto before, but once that ball comes out, you know, again, it doesn't go back in. So there's an implied restriction there again. So there's an implied restriction. I have to reduce that amount, right? There's 1 ball that's come out, so it's 44, and 43, and so on and so forth, right? Until we get down to that 6th position there. When you evaluate it, is it quite a large number? Or?
Yeah, how do you win the lotto?
It's impossible.
5 billion.
5 billion. It's like 5 billion. Are you serious? See, that's why we say, mathematicians, like they know the odds of winning the lottery. It's not very high, right? Even if I bought, I'm not going to evaluate this because it's such a large number, but this is correct, okay? Even if I bought 10 tickets, right? If I bought 10 tickets, what would be my probability of winning? What if I bought 1 ticket? What would be my probability of winning?
1 out of that.
1 out of this. So if I buy 10 tickets, I'd be 10 out of that, right? Because there'd be 10 different numbers there, right? So now we can see how this ties in with probability, and this actually is a really big aspect of how we try and think about what we call the sample space. How many possible outcomes there are, right? So in this case, I've got 10 favorable outcomes. There's 10 situations where I'm winning.
What's the chance of winning if you...
What is the chance, actually?
What's the chance of winning if you buy 10?
If I, oh.
So it's about...
0.000000017.
So you want to buy 10 lottery tickets, that's your chance.
Does it convert to a fraction by any chance? Does it work?
No.
No. So it's 0 point, and there's like so many zeros, and then 17 or something like that. It's so unfathomable, okay, that there's even if I bought 10 tickets, there's not much chance of, I mean, you could buy 100 or 1,000 or whatever you wanted, right? But still, there's a very small chance of winning. And every lottery system is different, but this is just to give you an idea of, hey, okay, this is actually what's happening here. You always hear about those stories that, there's this random guy bought one from a newsagent, everyone wants to be a part of that. But unfortunately, the chances of that happening are quite low. But